Okay, great. So we'll start. This session is JAM382 Open-Source Game Middleware. Pick the weapon of your choice. You like that title now? So I decided I wanted to do a talk on letting people understand kind of options that you have when you're writing a game. I tend to get a lot of questions from people trying to walk down the path of like, what should I use? Should I use this? Should I use that? And I was like, potentially that could be a good talk. And so today what we're gonna do is hopefully the takeaways are we're gonna go through some kind of game planning, go over some game architecture, cover some different options for open source game engines. I'm gonna have a case study where we're gonna do the guys from Touch Dimensions are gonna come up and they're gonna show me a demo, and then they're going to talk a little bit about their experiences with the Ogre framework, and then I'm going to talk pretty in depth in code about one of the frameworks that I was the co-founder of called Gameplay 3D, and talk about design of the classes and how we did some particular things in there, like integrating physics and scripting, and hopefully give you a sense of what you will be dealing with if you decide to go down the path of kind of either using another open source framework and what that's involved. So my name is Jean-Paul Taylor. I've been working at BlackBerry. Previously I worked at RIM, by the way, for about 8 years or longer. And I've been at BlackBerry for a few weeks now. So it's and my email is setaylor@blackberry.com or @rim.com. They both work. The day they announced it, I actually emailed myself right away. I'm like, oh, so that must work, BlackBerry. Emailed it. And then this is my Twitter account here. So if you ever have any, I love talking to people generally. If you have any emails about anything, even non-BlackBerry gaming related, I'll talk to you about it because I love everything about gaming. I'm a pretty enthusiastic game developer. A lot of the game ventures that I do with friends and buddies usually is after work hours, and it's usually till 4 a.m. in the morning when I fall asleep with the keyboard on my lap or something and wake up and, fun stuff like that. That's when all the adventures happen. So let's start off. You want to write a game. You got this idea. You and your friend, you're like, you want to make a game? I got a game idea. It involves this and this and this, and you're thinking about like the last game you played or something you did, and you're like, I'm going to make that because I can do it. I'm a good programmer now. I can write games. So you end up drawing funny little pictures like this about what your game's going to be about, and you have this back-end vision that this is the guy playing your game, like, this is the best game ever. So then you're like, okay, well, what's next? Like, what do I have to do next, right? So first of all, with kind of like a fundamental game planning kind of philosophy, what I try to do is understand what you know and what you have for skills and what like choices you think you should do before you like go the wrong path and then say game development's not for me. Because I don't think that's a lot of times people just make the wrong fork in the road and all of a sudden you're at some bar. No. You take a wrong fork in the road and then you have a problem. So I break it up into these categories. First of all, like, what's the art or the style of the game that you want to do? Is it going to be 2D, very basic rendering, or is it going to be more advanced 3D rendering where you're going to have to know a little bit more about how to do these kind of things, even how to use another person's class? It gets more complex when you get into that. What kind of skills do the people that are going to be working on the project, what do they have? Do they know how to do web pages and therefore only know JavaScript and kind of like declarative kind of design? Or are they able to actually write C++ or C code to actually write the code and get their hands a little dirty into that? So, I'm not saying that this is one person and that's the other. Do I have a development team, or do I have a design-ish and a scripting kind of team? Therefore, do I want to rely on building IP or investing in open source IP? Buying IP, trust me, if you do not have the skills to do game development engine stuff, or even use frameworks that you're going to have to write more C++ code to use that code, or scripting on there with some modifications, you could get yourself into a world of pain if you go down the road of, I'm going to do it all myself. So take a serious consideration about something like Unity, which has a couple different languages. They have an editor. They have an ID. It's a professional environment. It supports all the platforms. It has a packaging on the end. It has, like, you get what you pay for. And it's an amazing development tool set, right? So something like Shiva, the same thing. That's the little blue, purple. These game frameworks, they've done the work for you. I mean, like, this is what you're paying for. And it's supposed to be good quality, and it is. So really take a serious consideration about which path you, because once you go one way till the end of the title, you'll do a post-mortem and say, I made a mistake and I should have actually chose Unity, because all I had is a bunch of designers and a bunch of people that set the world out. And I had some guys that were tech-savvy programmers, but they're not like hardcore engineers that took computer science and actually know how to properly organize code and all this kind of stuff. So you have to make some pretty realistic and logical decisions before you get going about technology choices. So we're going to tap a little bit into the far side over there. I'm assuming that a lot of people here are developers, so we're going to talk a little bit about actually writing a game framework and actually about using libraries in your own game engines and how you can incorporate them in. So this is a typical game architecture. Drew this up pretty quickly, but what you're going to try to do is you're going to have a set of tools that you're familiar with designing with. This can be like Maya, there's design tools, there's art tools like Photoshop, and then you're going to have editors if you're a programmer or IDEs. So you're going to write a lot of your code. This is the code you're going to write. You're going to write your game logic and your code and your scripts that are based on some fundamental framework. It's going to have your game assets that are packaged with the game title there, and then you're going to have a section in there which is the engine components that deals with a lot of different things we'll talk about. And then there's the platform layer, which really handles input, windowing, file I/O, all of your standard kind of things that are somewhat quite different in some of the different platforms. So that's an abstraction layer that you can actually cut off. And I did a talk earlier on porting, but I have some good reference for that if you want anyhow. And it's inside some of the frameworks that we're going to discuss. So for the engine components, it's good to understand kind of like the lay of the land here. So I mean, graphics is obviously one area. That can cover anything from windowing to like drawing. So you're drawing text, you're drawing sprites, you're drawing 3D mesh, you're drawing more advanced rendering techniques like water, sky, a variety of different things. You're going to have a library that just purely focuses on audio. So a lot of times if it's a 2D game, basic core audio or things like that are fine. For a lot of this, you'll see that there's other options that you can use that'll give you some more flexibility. For physics, this is just something that's quite different per game, and we'll talk about why. And then you got a potential for scripting if you want to do scripting in your game. And then the areas that I'm not going to really cover because it depends on the game, and I will talk about it in one framework later, but you have your game scene / user interface. Those are kind of two models of data that are usually integrated into your game, and then they'll be built on some core libraries such as math, networking, I/O, that hopefully you can use most of the code cross-platform and potentially only put the abstractions in some of the I/O for opening files and doing things like that. Sometimes you have to put that in the platform layer also, though. So with the graphics device, you have OpenGLES 2.0 is pretty much what a lot of people are using nowadays. It's broken up into 3 chunks of kind of classes that you're going to do. Some of them are purely about hardware resources. So this is like your frame buffer, vertex and index buffer, your textures, and your program and shaders. So this category of one all defines hardware resources that you're going to actually acquire through the creation of these things. They're usually done and loaded, and then later they're used in bind, and they're used at runtime. Shading is really the mechanism for creating resources that are going to be bind at runtime about how it's going to look and how the actual surfaces that you're drawn are going to be applied onto them. That includes render state, how many passes you're going to take to render it, and the techniques that are associated for potentially combinatory shader combinations. And then the effects are going to be really a mechanism for just keeping a handle to the program, and materials deal with the parameters that get set in on the individual object. So materials are typically one per object. They're not really shared, where effects and techniques, those are programs. They can be they usually keep handles onto data in the hardware resources. Then in the rendering side, this is your scene, node, camera, light, model, mesh, sprite, batch, font, kind of like rendering classes that use the shading and the hardware resources. Oh, and one little trip, some people have been always asking me, can you use OpenGLES 2.0 on mobile for everything? You actually can, even though Windows in their not so bright wisdom decided to not include OpenGLES 2.0. Someone in their spare time made a little project to kind of wrap and do a OpenGLES compliant driver on Direct3D 9. Go check that out. It's kind of a workaround, I think, for Windows Phone 8 to kind of fill their deficit that they basically blocked. I don't know why. Actually, all the drivers, every single driver that the hardware has OpenGL and a Direct3D version, and I'm surprised they blocked it, but okay. OpenAL. So I recommend to everyone for games to use OpenAL. Basically 1.1 is the version that everyone's using. The hardware resources are just the buffer, really. Behind that, usually there's a couple mechanisms. You either load it or you can stream it in. A lot of times loading is a practical way. Another option is a load with a lazy stream. So you're basically lazy loading. You just buffer up what you need, and then you stream in for the load. But you usually just need it all loaded. It's not like music's different. Sometimes you might want to stream the music. So there's some different ways to actually do the buffer, whether you want to versus load versus stream. And then for playback, you have a listener, which is you, the user, and your position, basically. And the audio source is actually is basically like an instance of a buffer at a location in your scene, so that you can potentially have 3. So OpenAL does support 3D. Watch out on Android. OpenSL, most of the implementations don't support 3D in them. I've tried them. I was kind of surprised. I mean, the interface was actually for 3D, and most hardware vendors didn't put the 3D support in. So luckily, if you go to OpenAL soft, the implementation's on K-Strange. The link's in here if you look at the resource after. You can build the OpenAL software version on Android. It will work. It works well, actually. It's fine. And that's a workaround there. So for physics, you're going to really have to make a really definitive choice. Am I writing a 3D game, or am I writing a 2D game, or am I writing something in between, so then I kind of need 3D physics or 2D physics? So what I usually recommend for open source is Bullet. It's for 3D. It's one of the ones that's Erwin Koemans is the lead for that. He really knows what he's doing. We've worked a lot with him recently. I have a guy who's got like a master's in physics on my team, and he's like, I'll show you a demo of some vehicle physics. So we wrote some extensions on that. Maybe actually go into the Bullet physics next. But options for 2D are obviously Box2D and Chipmunk. Those are really good libraries. They support all the typical things. So physics is broken up into 2 areas. Usually it's collision and then dynamics. Collision is the shape and the callbacks and the tests that you can do to find out if I'm going to collide. It's tricky a little. Some people don't understand, like, if you have inertia and an object's moving in your dynamics area, the collision, they have to kind of work together to know. Otherwise, you'll do a test and you'll go right through the wall. and so the time matters, and they do these basically, they have these solvers inside the dynamics to understand whether or not it's going to collide. So most mechanisms have these common, there's a rigid body which represents something that is going to represent a dynamic object and how it's actually moving through a physical world. And then you can apply constraints on that. Maybe you want to put a spring, or you want to put a hard constraint on one side, or sometimes it's a chains or ropes. There's a variety of different constraints. They're different, but sometimes the same between 2D and 3D physics. But I think once you learn one in kind of like a abstract, primitive way and understand the fundamentals of them, if you were to go to do a 3D, you could kind of pick it up quicker. For scripting and your script controllers that you're going to write, you're probably going to use something like Lua is very fast. It's great for games. Some people don't like Lua, how to code it. I'm actually impartial. I'm fine with Lua. Lua's great for me. I think it's a good scripting language. Some people like JavaScript. The V8 engine's a very fast engine. It's become pretty popular in games, and then you can use Mono as well. And so a lot of these libraries that I'm talking about, we've already ported them. They're already on GitHub. You can go and use them in your game. If you already are thinking of writing a game, or you have some code that you want to work with it, you can go to blackberry.github.com, and all these libraries are already pre-built for you. And there's projects there that you can import in, just build the code, and you can shove them right into your own code project right away. So when we're talking about game engines, I'm going to separate those two off again because once again, I know that most games have some 3D and 2D, but I mean, it all depends on what you're going to try to do. Sometimes when people write a 2D game and they want a little bit of 3D, they may not use a 3D engine, but they may just decide to write a renderer for just the model. And I talked to the lead of Cocos 2DX, emailed me, because I'm the lead of the gameplay, and he says, hey, how do I add 3D models in Cocos 2DX? And I said, well, people have to decide early, am I going to be a 3D game or am I going to 2D game? And if you can't just make just an avatar running, right, that's it. But funny enough, that's truly what people sometimes want. They want some character or something like that. So I usually recommend Cocos 2DX. I talked to someone else. Another good one out there is there's a libgdx. We haven't ported that one yet, but it's popular out there. Cocos 2DX has a huge following. There's like 2,000 watches on its GitHub project. Love 2D and NME are kind of some new ones. It's a very primitive 2D rendering system, but it's all script driven. So if you actually want to use a framework, you don't want to do any licensing, you just need some basic games. I'm going to make the flower picker game or whatever your game's going to be, and you just want to write a little bit of script, or you've got some old JavaScript guys and they kind of can be tech savvy. Those are good options for you. If you don't want to learn a little bit more set of classes that are included in something like Cocos 2DX. But Cocos 2DX is an amazing 2D framework. There's a lot of top games that use that, and they're like released on the stores. So I mean, believe it, that's a good framework you can use. When we're talking about 3D engines or frameworks or rendering engines and all that, these are the three that kind of came to mind for me that are mobile. So for all these, I've said open source plus mobile. There are other frameworks out there. There's Urlect as well in 3D. But so Gameplay 3D was one that I co-founded with another colleague. We had been doing late night programming projects for a long time. I did like deferred rendering systems and like really, really high-end graphic systems with DirectX 3D11 and a 9 renderer before that. And you know, we just put so much time in it. I was like, oh, okay, work here now. I should kind of contribute this out to the community and be a good citizen. I'm not here to like just do this. I want to actually be part of the community. And I think that's a really big, important part of open source is that people share with each other ideas. You go to game conferences to share your game idea. It's not there to like win one over on the other guy. I'm happy if you write a good game. Good for you. Awesome. I get to play your game. We all want to play good games. So I mean, with open source, it's kind of like sharing even the layer below. Like, this is what I learned. Let me share my cool trick with you. And I think that people should start to understand how that is important for us all to have better programmers and people that understand the technology. When people only understand way up here, you end up getting really bad games down here eventually. So, and the libraries become not that great, and then the games end up being bad. So one of the ones we recently worked with another company, Macadamia, and they helped us with this port, Ogre 3D. That was an old school rendering engine. It's called the object-oriented graphics rendering engine, and I'm going to bring up someone after that's going to talk about their case study on that. Then Oolong is one by Wolfgang Engel. He's like a renowned like graphics guru. Met him a couple times. He's like amazing graphics guy. So his engine really right now is only iOS. I think he's putting Android stuff in. We didn't port that one yet. It's really like rough around the edges, but there's some gems in there for sure, and like optimization shaders. I was able to like look at some of the math neon code in there, and we were able to put it into our framework as well. So next I want to just call up Travis Ho and Jeffrey Jiang. These guys, you guys probably already saw their demo. They did a demo where they showed off their game Autumn Dynasty, and they're here to show a little demo on the game and talk a little bit about their experiences using Ogre. So you guys can come up. You can just use the mic. You guys can just use the mic here.
Right. I guess today he gets to speak. I'll manipulate the device.
Yep.
Well, go ahead.
Okay, so maybe I'll start with the story. So what happened is during January when Justin from BlackBerry come to tell us that, hey, is it okay to port your game over? And we give him quite a tough problem. Is they have to port our game engine, that's Ogre 3D, to BlackBerry before we will start. And amazingly, it happened. So Sunday, I mean, I thought I would have a relaxed start of the year. I mean, it's just January, but I end up spending the last 2 weeks working on this. Okay, so maybe let Travis show you a bit of the game.
Right. So
And he'll flip it here. Which one is it? HDMI. There we go.
okay. Yes.
Okay. So despite we are using a 3D engine, this is a pure 2D game. The reason we use 3D engine because both of us are we work with 3D games for many years. I think about 10 years or so. So it's a lot easier for us to continue using the same engine, the same tools that we have built.
So you guys wrote this on iOS originally, right? That was your
Yes.
target. So what was your experience other than the engine, bringing the code base over?
Okay, so before iOS, this whole game is run on PC. The main thing is we do not like the long deployment. The game is quite huge. It's 300 megabyte. And every time we want to deploy to BlackBerry was, okay, I need to wait for like half an hour before the game will actually start running on the device. So to speed things up, so we just run it on the PC and we can do our coding and it play.
So this went through several different engines and implementations. It went from PC to like Windows Mobile, then back to PC again, then back to iOS. So we had a lot of experience moving this thing around previously. But I mean, compared to that, maybe you could tell them about the BlackBerry port and how it was a lot less painful than the other things we endured previously.
Yes.
Thank you. That's nice.
So after that, we decide to stick with BlackBerry and stick with Ogre because it's a cross-platform engine which run on BlackBerry, PC, the iOS.
Well, if you guys are familiar with other game engines, right, XNA has just like gone off or gone out of existence, right? And it was on XNA for a while. So it was on Ogre, then went to XNA, then went back to Ogre again. Yeah.
And surprisingly, bring it over to BlackBerry is a lot easier than the iOS. So we go on the PC, but bring over BlackBerry. I mean, since we have the iPhone version, it's just a recompilation of the engine. We are using a few open source library like Boost, so that is just a recompilation and it works. So we did encounter a few problems during the port. One of the problems is previously the whole game looked blue. So I was showing everyone, hey, what happened? The game looked blue, and we discovered that during the transition, the image, the codecs actually read the blue and the red channel. They flip the blue and the red channel. So
RGB.
yeah, instead of RGB, they use BGR. And when it's free black, yeah, it looked normal.
And that was in free image, right?
Yeah.
Yeah, it was in the free image code. We had to find that. Yeah. So fun. It thought it was little endian.
Yes.
Sorry, it thought it was big endian, but it wasn't. Okay, well, thanks for showing that demo. I'm going to just keep going on now, and then you guys can hopefully release this game soon, so everyone wants to play it.
So I think for developers, right, part of it is actually the port, then like trying to make sure that everything works well. I think the other part that we're looking forward to going through, right, is actually how we are going to get it onto the store and how to get it, or how to get like whatever we are selling, right, back from the store as well. I mean, we've had certain experiences with like other platforms as well, so hopefully this will be a lot better as well.
So far everything seems quite good. I mean, we only spent about 5 hours, I think 5 full working days. Even though it's 2 weeks that we spent working on it, but it's because we're also working on another project, so it's only about 5 full working days. Those Justin from Singapore was like chasing us every day to please get it ready for the trip.
Okay, cool. Thanks. Thanks, guys. Let's push it back to the PC.
We'll be sitting right behind if you are interested on the game or what are the problems you encounter again, feel free to ask us about that.
Just like after the session, we'll be around. We'll be available to answer any questions you guys might have.
Yeah, for sure. Yeah.
So look forward to hearing from you guys as well.
Cool. So I thought I'd talk a little bit about this. I've never really had a chance to talk a lot about this in the past. A lot of people, I got crazy amounts of email now about this because this was kind of a pet project for a while that we had been working on. And a gentleman, Steve Grenier, and myself, we had worked for 4 years on basically a high-end engine and decided to rewrite it all from scratch just to kind of gift it out to everyone. And we said, well, my boss is like, do you want to do it for BlackBerry only? I'm like, come on. I'm like, my reputation's on the line. so no, when we did it, we were like, if you're going to do open source, you got to do cross-platform. You got to prove your engine's going to work on all the different frameworks. So we wrote it on BlackBerry 10 and Playbook, of course, iOS 5 and 6. It works on Android 2.3 and Jelly Bean. It works on Windows 7. I've tried it on Windows 8. It works. It works on Mac OS X, and it works on Linux. We tried it, and we've only really tested on Ubuntu, but there's 4 or 5 other guys running other distributions on that they were telling me about that it all works. So truly cross-platform, not just saying that. The framework's written in C++. It's really, really well documented. It has IDE solutions and workspaces for Visual Studio 2010. It's easily convertible to 2012. It works on Xcode, the Eclipse CDT with the Mementics, and then we also have CMake files for Linux. We have scripts on both Windows and then Mac Linux on your development environment for generating a project that'll actually create an environment for your project that supports all the platforms, which is kind of interesting. You actually run the script and it'll create an output folder that has all the different tooling setups, all pre-set up. And a lot of people thought that was really good, that they could run that, and then if they're in Windows, they run the Visual Studio project, it's up and it's actually working. If you run the Xcode workspace, it's up and it's working. If you basically are using the Mementics IDE, you can import that and it's all working. So that was good. We have a game developer guides. They've been converted all to they're online on a wiki now, but they're pretty good developer guides, tutorials. It supports a binary encoding tool so that you can convert TrueType fonts to basically texture fonts, and then also supports Claude and FBX import for 3D models and assets. And it's open sourced under Apache, and that's the URL if you guys want to go and get it. Check it out. These are just some pictures of kind of some screenshots and some of the samples that we have. So the development environments, I just covered them there. This is the development environment you're able to work in. In BlackBerry, we do have Visual Studio 2010 plugin, so you can actually do Visual Studio on the BlackBerry. That's kind of cool. I wanted to make sure everyone knew you can actually use Visual Studio now to do your BlackBerry development. And yeah, so that's the environments there. So for the content pipeline for using this framework, it's pretty typical. Designers can use things like Maya, Max, and Blender. You can export out an FBX or a Collada DAE file. Artists can use Photoshop files or GIMP or whatever tools you're going to make your fonts in, and you can export out either maybe you're going to use compressed textures. That's what that crazy checkboard's supposed to mean. PNGs or TrueType fonts, and then those can be fed into the encoder to produce a gameplay bundle, which is a .gpb file, and then you can load that directly in the engine. And then the programmer, he can use Visual Studio, Xcode, or whatever the tools they want, and then they can write in C++ or Lua, and then you're going to bring that into the game. So this is kind of like just a walkthrough of, there's more methods than this on the class. So all you have to do in your code is extend a game, and then you're basically going to implement your initialization, finalize, so for your cleanup, and then update and render. That's going to happen every frame. And then you're going to have a lapse time. Originally, we had long here, but there's precision issues, so float's better. So if you want to handle input and sensors, there's more methods than this as well, but these are kind of simple ones. So these are going to be methods that you override. If you override the mouse event, you can return whether you want it to be also handled for touch event. So because sometimes you want it to react the same, so you might as well just have the same implementation. But BlackBerry as an example, good example, you can actually attach a Bluetooth keyboard and mouse, and you can actually play your game with an actual keyboard and mouse, which is awesome. So we support that, of course, so that you can actually sit on your couch and play your game on your BlackBerry and attach it on. And I'll show you a cool demo later for that. And then we have methods as well. So these are kind of the event ones, but then there's methods as well, like show the keyboard now, or register a gesture, and then you can actually get events back on it. So if I want to draw something simple, a lot of people are just like, well, how do I do 2D? I just want to do some simple 2D stuff. So let's say I want to actually just draw something with a font that I have. So this GPB was originally a TrueType font. Let's say it was called Arial. So I would have actually sent the TrueType font into the encoder, said I want it to be size this or this, and usually go a little bit bigger. And then I want it to be bold or whatever the different, and then it's going to produce you a GPB. So you just load it with this. So you're going to create a font. And then in your rendering code, you might clear the screen, start drawing the font, draw some text, and then finish. So you can see kind of like, you can kind of almost feel the hint that this is batched, right? So all the text is all batched in there. We don't draw every glyph individually. It's all batched based on the material or the font that you're using. So all the font on the same, all the text on the same font can be batched together. Even if it's the text is here or down here, we'll put degenerate triangles in between and actually make sure it's all batched together. And then when we use like a kind of like a reference mechanism. So we have a font you release down there. For drawing sprites, it's pretty much the same. You can create a sprite batch. That image might not be a single image in your game. It might be a texture atlas that has several images in it. Like that's what I usually recommend to people. So what you'll do is you'll create a sprite batch, and then what you can do is when you're going to do is you're going to start the batch, and then you're going to finish, and you can do as many draw calls as you want in between. You can specify the source and dest rectangle. So this one is only using one image, actually. If the source is the dest. So we're going to go from a full screen window. That's not a good example. Don't put window width and window height for the source. Yeah. And then for the finalize, you finalize the batch again. So let's say I have a 3D scene. I have an example where I'm maybe running some scene, and it's got a duck in it and a camera and a light. All you have to do is you load the bundle. Then from the bundle, you load a scene. You can find the model, the node that you want, which is the duck node. Then I might want to find the directional light and the camera. And then in this sample, every frame, I'm just rotating the duck. So that's the model node. And is that what I called it? Yes. Okay, good. And this is just rotating it at a constant based on the elapsed time. You can animate it if you want. There's an animation framework built in it. And then if you want to just render the scene, we don't have a scene renderer. You draw what you want. We have visitor patterns in there so you can traverse the scene if you want. So what we can do is you can register a call. That isn't actually immediate callback. It's actually basically going to call that method right there. So you're saying visit, and then the class handle to do the callback on the scene is the draw scene. So this draw scene will get called for every node in the scene, and you're going to basically be able to you can put custom data if you want in there on the callback. So if you wanted to put in a Boolean there, so you could cast it to a Boolean or an integer to say that these are the transparent objects. So let's say you want to traverse the scene twice, one for your opaque objects and one for your transparent objects after. You could do something like that and do tests. So and then in here, I'm going to get the node, get the model. If there is one, then draw it, because you may have a light and may not have a model attached. And then so if I want to skip non-visible, like you don't want to draw things that are not in your 3D scene that the camera does not see. So we have also bounding boxes and bounding spheres inside there. So every node has a bounding sphere for an early rejection model. So you can always just get the bounding sphere and check it against the camera frustum and reject out anything that's not within the camera view. So there's other ways to do that with physics and stuff later that we'll talk about. So what is the scene? In your game, this is basically your world. So you have a root container of nodes. It defines like a tree hierarchy of all the nodes. And nodes can have basically, they inherit some things above, and all it's really inherited for the most part is transformation, because a node is basically a object space transformation on everything below that. And then a scene can have one active camera at a time. Even though you may have other cameras attached to nodes in your scene, you can only have one active at a time. That's what the actual user sees when they're playing the game. And we have a visitor patterns for, visiting and of course traversing. That means that you can find things in the scene if you want. You should look them up ahead of time unless they're going to be changing a lot. So the node inherently has transformation, animation, and scripting support right on it. You can kind of see a rough breakdown of it, and it's reference counted. So you can control using safe release mechanisms. We don't do, smart pointers. It's not the safest in games, I find, to really use smart pointers so much. I mean, you may be good at that, and that's good, but it's just not finding your dangling pointers is sometimes more evil than crashing hard immediately and or running out of massive memory and tracking that. So we have memory debugging tools inside of it. You can also have tags on nodes, so those can define characteristics like whether this node should be opaque or whether it's transparent or whether it's part of a tree. They can combine tags as well. So when you're traversing, you can just look at these strings or put data in them or do whatever you want. We also have an arbitrary user data pointer, which you can get called back on when you get when you get cleaned up or released. And you can also have components that are attached to nodes. So the typical things that you attach onto a node might be a model. A model can be a plane if you want to write a 2D game and it's just literally a 3D plane, but you're not really using the Z at all. That's fine. You can have some 3D then in the game, and most of the game is just a bunch of planes, right? Or billboards. So models can be anything from a plane to a 3D model like Seymour down there, typical Collada guy. You can attach a camera to a node. You can attach a light to a node. You can also attach a physics collision object to a node, which will allow it to define physics characteristics, such as defining rigid bodies or ghost objects. You can put particle emitters, terrains, audio sources, forms, AI agents for actually doing scripts that run all the time if you want to do AI scripts, and then user data. So how do we integrate physics? So interesting thing about physics is what we did was we just extended Bullet. It was pretty easy. We didn't use every feature of Bullet physics, but we basically extended all the core collision and dynamics, and we supported constraints and things. So we have a thing called a physics controller inside there. You can create objects off that, and then we attach them onto the node. So then it actually acts. So you can see here, this is a physics character, and I will do a quick demo here. Let's see if this guy's. Bam. And let's run this guy. I'm going to run it in the PC here. So what's this number? 1. Cool. Hey, buddy, how's it going? So you can see here that this guy here, you can see the bounds on him. So we've integrated physics here. So watch, if I push these things here, they're actually going on there. You have a typical physics character controller, you have to handle that. So see how it falls down? So that's not really done that well. You can see when he's near the wall, look, his hands kind of go through. So what we've done is we've allowed you to define inside kind of like a physics file some more granular control, the actual physics character on what his bounding box is. So if I run over, oh, you saw we got some funky, so I can see through the guy. He can come up and grab something. I'll turn the bounds off. Or those are the different bounding box models. And so I'm going to kick the ball here. Hey, how's it going? And I can come up here and you can see. So it basically reacts with everything. This is just kind of a brute force. See if I can get it inside here. Oops. No. Okay. But you can see that you can have fun writing it. This is a simple little room. I mean, you get into something a little bit more crazier later. I have some startup programs tests in here that you can kind of see. Let's see if I go down to collision objects. So you can start having fun right away, dropping the balls. If you want to put them here, drop a bunch of boxes, stack them up, then throw a box to hit it and smash it. Fall. So we have a bunch of test frameworks to let you play with it, but physics is kind of tricky. One of the things that you have to watch out for is putting the right characteristics and making sure you're picking the right shapes that you want. So when we get into something that's a little bit more complicated, so I'm going to switch over to HDMI here. So one of the things that we've added in here, let's see if this goes on now. Cool. Is that going to pair? Oh, maybe I got to turn this on. 2, 3, 4, 5. Cool. Paired. Oh, there it was. It was connected. Okay, so you can see that. So this is a SteelSeries free remote. It's a Bluetooth. I've paired it through here. One of the things we've added into the platform recently is the ability to do kind of big screen gaming with the gamepad. So I'm gonna launch. This is a little sample of a game. I don't know if this. Do you have audio on the HDMI or no? Oh, don't worry about it. That's okay. So, woo, there we go. So now I'm using basically, you can see I got some vehicle physics in here and funky little camera. So this is just a sample we kind of whipped up. I had an artist, Elaine. She did the 3D world. Didn't take her too long. You can see a lot of the shadows. They're all baked shadows inside there. So let's see if I can. This is a really tight course, eh? You see that? Oh, check it out. Oh. And I think the aspect ratio is wrong on here, by the way. That's why the road is really narrow. And I'm going to stop that, okay? So you can see, so one of the things that we've also added into the gameplay to integrate physics is a vehicle physics. So what that is you have the body of the car, and then you can attach wheels on. And so those are child rigid bodies of the actual basic collision object. So what you do is you basically extend the core classes that Bullet's using for all of its collision objects that have rigid body. We apply constraints into this thing, so you can see how we've basically written classes that extend our own core classes right now to actually give you a physics model. The way that we did the physics in this terrain is like all the rails are actually, these are actually collision objects, right? The trees, if I were to flip out, we actually jump out in the air there, and then there's an off-road part later, and we do basically collision objects for every tree. But the Bullet physics engine does have like a wide pass kind of solver that rejects off things that are not in the scene, and anything that's static is a much easier test as well. So yeah, that's an easy way that you can integrate Bullet physics into your own game. You can take a look at this code here and just see how it's done. So kind of a gem that I thought I wanted to share with someone on a cool idea on how to, a lot of people are like, well, how do you do your scripting in your game engine? I like to add scripting in my game, and I want to know how you guys do it. So I've seen it done many, many ways. I mean, like, one way is typically you're like, oh, Lua extends the Lua state, and then what I'm going to do is I'm going to just basically write a wrapper class for every one of my, and I'm going to hang write these. Very error-prone. You're going to have consistency problems on how you write one class. Like all of a sudden, Bob is writing those 4 classes. Dave is writing the bindings on these classes. The way he does his bindings this way, the way this guy does this bindings is this way. You end up using your bindings, and you're like, these suck. These are really bad bindings. Like, who wrote these, right? So we said, let's like try to take this in a more procedural manner, because we're programmers and we can figure out a smarter way to do this. So what I did was, we take the doxygen, we generate the doxygen on your own API. You then take the XML, generate it as XML, or there's HTML. You just have to write a parser then. And what you do is, Doxygen's a really good parser. Like, it's actually a really good code parser, and it knows what public interfaces are and which ones are protected, and it gives you all the information in there that you could generate derivative interfaces from a scripting language off of. So what we did was we wrote a tool called Gameplay LuaGen, and what it does is it basically parses the XML Doxygen folder. We have a builder pattern that basically then interrogates the output of that, and we basically then build our own generated bindings off of that, following the exact pattern of that. So some of the challenges that we faced a little bit, first of all, it works really well. Like, you're like, man, I just generated the entire bindings of every public interface and protected interface. And we even did polymorphism. We were like, okay, well, we started creating up our own tables, saying this class extends this. So when you're parsing the Lua out, sort of the Doxygen output, it'll tell you that this class extends this. So you can actually build up data structures to actually build inheritance tables and actually then go ahead and put in the code. So one of the challenges we faced was we put duplicate code. I didn't put that on here, but there was duplicate code. We're like, oh, we generated the same code, even though it inherited in both. So then your compile times get longer. So we're working on optimizing that. You kind of like learn from your mistakes. Object creation. So we have a mechanism that we can create objects and then we can release them. Those are like reference counted. So if multiple people create a texture, you're not going to have n textures. It's just going to be reference counted that many times up. And then it's going to be, well, Lua kind of decides that it can hold on stuff forever if you want, depending on how you do the actual Lua state. So what we did was we do manage through the GC. We do manage through the GC in the Lua, but what we do is we can if we're also doing ref controlled inside the Lua script, we just added this little thing in the Doxygen tag called script ignore. And what that'll do is says, don't do the Lua. What we do is we tackle the Lua GC separately, and it'll Lua GC on a separate time frame of it. So that's one way that we handle that. And also, Lua tables and arrays is kind of tricky as well. So, you know, when you're comparing the two, probably think about C++ is great because it has early compiling, so early error detection through the compiling and the tools that you have. You have strong types to work with, and you have support for debugging and profiling. If you're going to choose the Lua path or JavaScript or Mono or whatever scripting language you choose, it's awesome because you can prototype really fast, especially on desktop. I mean, mobile devices, you always have to upload the updated script all the time or drop it on a shared location. But I mean, if you're, most of the code is all cross-platform anyhow, so you're going to just run on your desktop, iterate, like make a line of code change, and then it's really easy to learn because the way that you can do it, it's basically identical. And then I'll even show you here. Here's a really quick example of how this code here. I have a Lua sample. Set as the startup project. So this is just this here. I can do things like this. This is essentially a spinning, doesn't do anything, right? It's just spinning all the time. And I have a test here with a mesh, which is doing the same with the duck. So the code in C++ inside here is going to look like something like this. So you can end up seeing that you have your initialize, you create your font, you create your bundle, and you have all this, and you have all these methods. But if I go to look at the Lua sample, my Lua game has nothing in it. And what I've done inside the game config is I've basically, inside the game config, I basically said these are my startup functions for the scripts. And then what I can do is I can go inside my game.lua, and I can have the exact same code. It's almost identical, actually. So if you like the code in Lua, you can code in Lua. You can see like there's the exact same code I just showed you for doing some text rendering. And yeah, I definitely recommend taking a look at the Gameplay 3D framework if you're writing your own framework. Even if you're writing your own and you just want really good reference, the entire framework is 99% cross-platform. Is platform independent, and all we have is these files right here that basically have your platform specific code in it. So that's about it. I wanted to leave the rest of the time for questions. Sorry, PC. I'm going to go back to that one there. So yeah, I wanted to leave the last couple minutes for questions. If anyone had any questions on anything, I'd love to answer them. Don't be shy.
Does Gameplay 3D
Yeah.
from screen to screen.
Yeah, so I'll show you. Here's a quick example. So inside the test framework here, show you a quick few little samples. Just take a minute. So if I go down here to, let's see, the form tests. So this is just a simple form. You have buttons, radio buttons, check boxes, sliders. This can be 3D, and you can actually select and type. You can actually see that. That is actually completely, if I flip the thing around and go the other side, you can't, because that's the back side. So it's actually accurate. You have scrolling. You can see you got flow layouts, vertical layouts. We're going to add a couple more things. I just put a control here on. That's a simple one. You can see inside the particle sample here as well, where basically what we have is, this is a particle emitter here. You can do smoke. I've got UI controls here. So if you want to actually control, I want to have different colored smoke, like maybe you want green smoke coming off your game. You can see that you can spin it. You can control if you want to emit smoke bombs or if you want explosions. So these are the kind of things that you can do with the framework to attach on. But hopefully, take a look. It's got UI in there. We're going to add a couple more controls, I think, soon. Any more questions?
Maybe, I know this is maybe a stupid question, just some research on internet I may find it, but do you plan to add support for Android developing on Linux, using the Linux?
Yeah, you can develop Android on Linux.
Because I think that the slide just said that I can develop Android with Windows and Mac OS.
Oh, yeah, you can do all of them. Yeah, actually. Sorry, that was a mistake there. Any more questions? Any crazy game questions? You can talk to me after too. Sometimes you're nervous to ask I have a really cool game idea. What do you think? No. This is my email, sctaylor@blackberry.com or rim.com. They both work. And this is my Twitter account. So if you guys want to follow me. Yeah. Which one?
I asked if it's possible to bring it to BlackBerry, and I received information that it's not possible, and you guys said that you're working on one.
What's not? Sorry, I still didn't hear what you said. Can you say it louder with the mic?
Is it possible?
Here's the,
Because I asked a couple times before, is it possible to bring libgdx to the BlackBerry?
oh yeah, it's
Is it possible? Because
course.
I receive
I
information
ported
this is not
Unreal,
possible.
every engine possible. I can port libgdx.
Okay, so I can assume that this is going to be supported in the future, right?
Yeah,
Or-
well, if someone wants that, and they ask,
I
not
want
even
that.
one person asked me, so you asked me now.
Okay.
So I'm
thank you
going to
very
tell
much
my
then.
friends
I'm
that
looking
back at my.
forward to it. Thank
Yeah,
you.
I got a bunch of Ninja programmers. They'll do it if you want. It's probably not too bad, because it's a 2D framework. I mean, it all depends. Usually, like we ported Cocos 2DX and a bunch of them. I mean, it wasn't very. Once we do this so often, we kind of know how to do it now. So, yeah. Now see, this is the way we work. You tell me what you want. I'm going to go port it for you. There you go. Any more questions? Anything else needed ported? Okay, thanks a lot, you guys. Bye.